So our definite integral is an area under the curve, and we can just find that by doing the definite integral. So there's going to be questions where sometimes they say, what is the area between the curve and the x-axis? Then you know that you could just find an integral and do that. So find the area enclosed by the line 2x minus 1. The x-axis and the line x equals 1 to x equals 5. Okay, would you need calculus? No. Could we use calculus? Yes. So if we had that and wanted to use calculus, well, that'll just be the integral from 1 to 5 of 2x minus 1 dx. Integrating is simple. When we plug in 5, plug in 1, and subtract the 2, and we get 20. And we didn't need calculus, but the calculus is almost just as easy. Like if I had to, what would I do? I would probably draw that line, right? But I would have to figure out how high this is by plugging 1 into my equation. So I'd find out that this is at 1. And I'd have to figure out how high this is by plugging the 5 into my equation and getting 9. And then I'd be like, okay, this is 4 times 1, that's 4. Right? And then this is going to be from here to here, this is 8, so this is 4 times 8 divided by 2, that'll be 16. And it becomes quite obvious that my diagram is perfectly drawn to scale. And then I'd add my 4 and my 16 together and I get 20. I think that actually would take me longer than doing the calculus in this example. Plus, if I was doing that, I would have had to have graphed. And I know you guys love, love, love graphing. So, okay. Here's the picture of the graph. Parabola opening down, shifted up 15 units. That does not look like something we have any ability to do with any formulas we know. So we would have to use our calculus. Okay, I'll give you a head start. I'll put up the answer in a bit. All right, you can check how you did. $49.3 as a final value. And you could double check it with your calculator as well. If you got this one, you can start the next one. I'll put up the answer. Did you just get pi? That's so cool. Could you have done this without calculus? The answer is yes. Because you would have been creative and said, I know my center line. Whoa. We are zoomed in. Okay? We'll zoom out here. And see if you like the logic here. I know my center line is at 1. This part here, above 1. Take it, flip it over. Oh my goodness! Fits beautifully into that spot. But then I have a tough area to figure out a rectangle with height of 1 and length of pi. So it was going to be a good idea, but it looks like it's falling apart. Isn't that cool? I like how I flipped, it just fits so nicely. So sometimes we can see areas if we cut things up and flip them around. Yeah. Oh, okay, there's